Since we learned power rule yesterday, today we're going to focus on product rule. Product rule is what we use when we are multiplying two functions together and want to take their derivative. Okay? So, say we are given a function p of x, and it is the composition of g of x and h of x, which means I'm multiplying g and h together. When I take the derivative, we take the derivative of our first function, g of x, so g prime of x, times the original second function, plus the original first function times the derivative of the second function. So there's kind of four pieces to this. Once we're done with that, we add them together and combine like terms where possible. So here's our first example of this. I have x squared times sine of x. X squared is going to be my first function, and then sine of x will be my second function. So when I take the derivative here, I need to take the derivative of x squared first, which is 2x, times the original second function sine of x, plus the original first function x squared, times the derivative of sine of x, and the derivative of sine is cosine. So then my derivative in total, since I can't combine anything, would just be 2x sine x plus x squared cosine of x. And then that would be it. So let's look at an example of another one. This example is going to be the function f of x is equal to 4x cubed times cosine of x. Again, 4x cubed will be my first function. Cosine of x will be my second function. So when I'm taking the derivative, I need to take the derivative of 4x cubed first. The derivative of 4x cubed, we drop the 3 out front, multiply it into the 4 to get 12x, and then we reduce our exponent by 1, so it becomes 12x squared, times that original function, cosine of x, plus my original first function, 4x cubed, times the derivative of my cosine function. Well, the derivative of cosine is negative sine. But it's 4x cubed times that negative sine. So when I simplify this, I'm going to get 12x squared cosine of x minus 4x cubed sine of x. And then that's it. Sometimes we can't simplify, sometimes we can. Next example can be done two ways. We're going to do each way. So this is the function n of t is equal to 11t to the 7th times t to the negative 2. As I'm looking at this, I'm going to split it into two functions. 11t to the 7th is going to be the first function, and t to the negative 2 is going to be the second function. So when I take the derivative n prime of t, I need to take the derivative of 11t to the 7th first. That becomes 77t to the 6th, because remember I multiply the 7 down into the 11, times the original t to the negative 2, plus the original 11t to the 7th, times the derivative of t to the negative 2, which is negative 2t to the negative 3, because I reduced my exponent by 1. Now I need to simplify. When I multiply two variables together, I add their exponents. So this one becomes 77t to the 4th, because 6 plus a negative 2 is 4, plus a negative 22t to the 4th, because 7 plus a negative 3 is 4. Then I have 77t to the 4th minus 22t to the 4th, 77 minus 22 is 55. T to the 4th, because they were both the same, I can put them together. So this was the first way of doing it. The second way of doing that exact same problem, rewrite it, is I could have multiplied that together first. I would have done 11 times 1 is 11, t, and then I add the exponents. 7 minus 2 is 5. So this would become 11t to the 5th. When I take the derivative of that, it's just power rule, which is what we did last time. which means I drop the 5 into the 11 and multiply it together to get 55. T to the 4th because I reduced my exponent by 1, and they are exactly the same. This one had a whole lot less work though. So as you're looking at these, make sure you determine what's the easiest route, okay? Because we don't like to do unnecessary work. However, they both did come to the same answer. So if you can't remember how to do it one way, then you can definitely do it the other way. Next example is the function f of n is equal to 2 sine of n times cosine of n. Whenever there's a number out front, a lot of kids forget where to group it. I always like to group it with whatever the first function is. So I'm going to put 2 and sine of n together to make my first function, and then cosine of n will make up my second function. When I go to take the derivative here then, I need to take the derivative of 2 sine of n. Well, that just becomes 2 times the derivative of sine of n, which is cosine of n. So I get 2 cosine of n times my original cosine of n that was already there, plus my original 2 sine of n times, well, what's the derivative of cosine? Negative sine. So this becomes times a negative sine of n. I can go ahead and simplify. I notice I have cosine times cosine, so that will become 2 cosine squared n. 2 times a negative 1 becomes a negative 2. Sine times sine becomes sine squared of n. So my simplified derivative here would be 2 cosine squared n minus 2 sine squared n. We kind of have about 3 more examples to go. This first example, you can read it in the notes. I'm just going to write the relevant information. So it gives me some pieces of information. Specifically, it gives me these functions solved at a specific number, which is 2. And it wants me to find the 2 products below. So the first one is going to be the derivative of the product, u times v. These aren't actual functions because I don't have any numbers, but I can still do it. So when I take the derivative, I take the derivative of the first function first, so u prime, times the original second function v, plus the original first function u, times the derivative of the second function v prime. Once I have that, all I need to do is fill in the values that were given to me above. I do that, I get u prime solved at 2 is negative 3, times v solved at 2, which is negative 1, plus u solved at 2, which is 3, times v prime solved at 2, which is 2. Then I simplify. Negative 3 times a negative 1 is 3. 3 times 2 is 6. 3 plus 6 is 9. So I get the derivative of uv solved at 2 is 9. So this would give me the exact slope or instantaneous change at the point x equals 2. Okay, all the other derivatives we've been doing have just been derivative functions, which would allow me to plug in any x value I want, and it would give me the rate of change at that specific point. Along with this one, I would also like to do the example d dx of 3u minus 2v plus 2uv. As I'm looking at this, I don't have to do product rule for everything. 3u is just a power rule problem. I just take the derivative of 3u, and that becomes 3u prime minus, well, 2v prime, because I just take the derivative of v, plus 2 times product rule on uv becomes u prime v plus u v prime. Just like I did, I take the values from above. So this becomes 3 times u prime solved at 2 is negative 3, minus 2 times v prime solved at 2 is 2, plus 2 times, well, I already did all of this, u prime of v plus uv prime solved at 2, and that's 9. I got it up here. Simplify it. 3 times a negative 3 is negative 9, minus 4 plus 18. Negative 9 and negative 4 is negative 13, plus 18 is 5. The other examples will be on the next video. It's almost time to go, isn't it?